Hello and welcome to this video on statistical distribution. This video is a part of our series on epidemiology and biostats. My name is Dr. Wahab Fazal and let us get into it. So the first topic that we're going to talk about is something called normal distribution. What is normal distribution? So what I want you to remember is just remember the bell-shaped curve. What is the bell-shaped curve? The bell-shaped curve looks as something like this. It's symmetrical. It has a very prominent peak in the center. This is where the middle of this lies, and then it has both sides equal and symmetrical. So what this means essentially is that in your population there is a repetition of one particular value, which is this, and both sides are equally distributed in data. Your data is equally distributed on both sides of this one particular value, which gets repeated again and again, and this is symmetrical. This is normal distribution. Then we're going to talk about something called a positive skew, or a right-sided distribution. That means that your data readings are skewed towards smaller values. So how that looks in terms of a graph is something like this. So assume if this graph has values on x-axis, let's say 1 and 2, and this goes on until 10, let's say. So now you know that the readings are skewed towards smaller values. This is positive skew. How I remember positive skew is that if you look at this diagram and if you look at it sideways like this, it kind of looks like a P. It looks like a P. So that's how I remember positive skew. And when you remember P is like positive, I looked at the graph like this, and this looks like a P, which is positive skew. You also remember that when you want to go on path, you need to go on the right path. The right path. Right path is the positive path. That's how you also remember the positive skew is also called as right-sided distribution. The positive path is also the right-sided path. So what you do is you look at the graph and see if it looks like a P. And how do you know this is not a normal distribution? Because if you draw a line here in the center, both of the sides are not symmetrical. Therefore, this is not normal distribution. This is positive skew because if you skew it like this, it looks like a P, and most of the readings are skewed towards smaller values on the x-axis. So what's a negative skew or a left-sided skew? Well, it's the opposite of a positive skew. The readings are skewed towards larger values, meaning most of your population is getting larger values. Same if we had 1, 2 until going, let's say, until 10 or 20, we know that most of the people, most of the class is getting values here, values somewhere around here. So this is where most of our data is lying. Therefore, reading are skewed towards larger finding, and that is a negative skew. So if you just remember that positive P looks like a P when you look at it sideways, then you will remember that this does not look like a P, and this looks kind of like an inverted N. If you look at it sideways, this looks like an N, does not look like a P, it actually looks like an inverted N. So that's how I remember negative skew. I just remember positive looks like a P, and then I understand this is not positive, so this is negative. And whenever there is a right way and the opposite way, so just remember negative is the left way. Negative is the left way. That's left-sided skewed deviation. Now we're going to talk about in this brief video about the measures of central tendency. What are the measures of central tendency? When we talk about data, we need to also know the measures of central tendency. So what are the central tendency measures? So mean, median, and mode. Let's talk about each one of these. So let's take an example. 4 students in a class have scored 10, 6, 5, and 8. Calculate the class average. Whenever someone says calculate the class average, they mostly mean the mean. Pun intended. So how do we calculate mean? You take a sum of all the values. You do 10 plus 6 and plus 8 plus 5, and then you count the number of values. So 1, 2, 3, and 4. Simply put, that's how you calculate mean. You just add up all the values and you divide them by the number of values. You must have done this before. This is how we calculate usually the class average. Then the next concept that we're going to talk about is 4 students in the class have scored 10, 6, 8, 5, and 3. You want to calculate the class median. You want to calculate the class median. What is median? The median is the middle value. Median, middle. Just remember median and middle. And you will remember that median is the middlemost value. So how you do this is that you arrange all of these numbers in a sequence. So this would be 3, 5, 6, 8, 10. So you write the sequence in order, which will be 3, 6, 8, and 10. And so what is the middlemost value here? Which will be 6. So this is our middlemost value. Let's assume if this was an even number of values, if you had 10 and also 11 written here, so what you do is that you take the middle two values and you divide them by 2, and then you get the median. In an odd number of values, it's just going to be the centermost digit, whatever it is. And in an even number of values, just take the middle two values and divide them by 2, and you will have your median. And that's how we get the median. Then mode. How you remember mode is, mode is the most repeated value. Mode is the most repeated value. Median is the middle value. Mean you can just remember as the class average, because that you must have been doing for a while now. Mode is the most repeated value. So if you had to take an example, a group of medical students measured their pulse rates, beats per minute during a stress test. The results are as follows. So here are all the values. And what's the mode of the pulse rates? So if you want to answer this question, we'll have to see how many times each number is repeated and what is the most common repeated number. So I think just look at this. I think 72 is repeated 1, 2, 3, 4 times. The number is 78 is repeated 1 and 2 times. 80 is repeated 2 times, and 75 is also repeated 2 times. So I think 72 is the mode of the pulse rate, because it's the mode which is the most repeated value. So mode is the most repeated value. So now when I was a student, actually in my 9th or 10th grade, I remember asking my maths teacher this question, and I said, you know, we have the class average. Why do we need the median, and why do we need the mode? What's the point of having median, mode, or even mean for that matter? So the thing is that these things in stats exist because different use cases, different type of scenarios exist in real life in which you need, let's say, basically a solution that gives you the middlemost value of the data, a solution that gives you the most repeated value of the data. Let's take 2 examples to understand both. We know that mean can be used to calculate the class average in a class. So what is median usually used for? For example, the government wants to know the median salary of the population. Why does it not want to know the mean salary of the population? Because some people might be earning way lot than other people, a lot more than other people, and when you calculate the mean, those outliers, those people who earn way lot more, who, let's say if this is the Bell distribution and there is somebody lying somewhere around here, let's draw this here. If this is the distribution and there's somebody lying somewhere around here, and you take the mean, this will skew your mean will lie somewhere around here. Therefore you need the median, which will be the middle finding, which will be somewhere around here. You want to know the middlemost value. Therefore there are used cases, but particular use cases exist in real life. Therefore government wants to know the median salary of your population, so it can gauge how much people are earning. Therefore you use median. When do you use mode? A use case that exists in real life is that, for example, a shoemaker wants to know the most sold shoe size in his shop, so that he can maintain stock of that particular shoe size for all of his available products. So in that case, he will use mode. So there are particular use cases that exist for each one of these modalities: mean, median, and mode. So now let us talk about where mean, median, mode lie in each type of distribution that we talked about. We talked about normal distribution, the positive distribution, positive p right-sided distribution, and then the left-sided skew or the negative distribution. So where do mean, median, mode? As I told you, outliers can skew the mean. So let's talk about that. So in normal distribution, all the mean, median, mode are the same thing. They're all the same thing. They lie in the middlemost thing. The middlemost value is also the most repeated value, and it's also the center. So in a normal distribution, all 3 values are exactly the same. So what happens in a positive or right-sided skewed deviation? What would be the middlemost value? I think just off the top of your head, first try to figure out what type of distribution this is. So this is, as you said, this is positive skew or right-sided deviation. Now, if I ask you to point out the middlemost value in this graph, which is the median, where will you mark it? I think you'll mark it somewhere around here, right? So that's where probably the middle value will lie, right? And what will happen to the median and the mode? What will happen to the mode in particular? Let's look at the mode. Where will the mode lie? You would say somewhere around here in the peak. That's where majority of our data lies. So if you look at y-axis is the number of people, n, which is the number of people, and you think the peak is highest somewhere around here. So this is where exactly most of your data will lie, and this will be the mode. So let's look at where actual data lies. Mode, which is the most repeated value, will lie at the peak, right? Median, which is the middlemost value, will lie somewhere around here, which was close to our analysis. And mean is affected by outliers. Mean is affected by people who earn a lot. Mean is affected by those people who are lying somewhere around here. Therefore, mean gets skewed here the most. Therefore, in a positive skewed deviation, in a right-sided skew, the mode value, because x-axis is increasing like this, so the mode value is the smallest on x-axis. If you look at it like this, the median is slightly bigger than that, and the mean is biggest of all. You need to understand this because this is sometimes tested in your exam, where mode, median, and mean lie on positive and negative distribution. If you look at left-sided skew, so this is a left-sided skew because it does not form a P, it forms an inverted P or maybe an N. So where would the mode lie in this skew? It would be somewhere around here, which is where the peak is. Okay, this is the mode. Where is the median? It's somewhere around the middle. It's here. And where would be the mean? It would be here. So in a negative or left-sided skew, it is in fact mean, which is very small than the median, and the median, which is even smaller than the mode, which is mode is the most repeated value, median is the middle value, and mean, which is just the class average. Now, let us talk about the measures of dispersion. What are the measures of dispersion? The one thing that we're going to talk about today is standard deviation. That's the only measure that I'm going to talk about today because I think that's the most important one that gets tested in your exams. So, what does standard deviation do? It gives us an idea about the variability around the mean. That sounds very difficult to understand. What does that even mean? So, what I want you to remember is these three values, okay? 68, 95, and 99, okay? I want you to repeat them with me. 68, 95, 99. Again, 68, 95, 99. 68, 95, 99. Do it again. 68, 95, and 99. What do these values mean? So let us look at an illustration and see what 68, 95, and 99 means and how standard deviation actually, like our previous definition says, explains the variability around a mean. So strictly speaking, this is a normal distribution graph. This is a normal distribution graph. And this is the most common type of distribution that usually gets tested in exams. So what does this line mean? What does this line? What do both of these lines mean? So if you look at this is where the mode, median, and mean lie. For now, we're only wondering about the mean, okay? So what this means is, on x-axis, if you took one standard deviation away from the mean, so this is mean plus standard deviation, and you take mean minus standard deviation, on both sides, around 34% of the data lies. On both sides, around 34% of the data lies. So for example, if you take somebody's English score in a class, and those English scores are basically distributed in a normal distribution. They have that normal bell-shaped curve, so that, for example, the class average is 10, and with a standard deviation of 5, so 10 plus 5 and 10 minus 5 will have data for almost 68% of the class. 68% of the class will lie in that particular range. So that's what standard deviation tells you. If somebody tells you that you have a standard deviation of, let's say 5 for an example, plus 5 and minus 5, in that range will have 68% of the data. So that's 68. If you get by a mid, you remember 68, 95, and 99, so you get the gist. If you start including two standard deviations on either side, if you start including two standard deviations, you add 13.5% on this side and 13.5% on this side, which makes your total to be 95%. So if you take two standard deviation on both sides of the mean, positive and negative, you include around 95% of the data. And then if you take three standard deviations, which is this small line and this small line on each side, it includes another 2.5% and 2.35% to be exact, and then you have 99% of the data. What that means basically, for example, if this is the mean of your data, if you move one standard deviation on both sides, you get 68% of the data. Add both of these values up, you get 68% of the data. If you move two standard deviations on both sides, you get 95% of the data. If you move 3 standard deviations on each side, which is somewhere around here, if you move 3 standard deviations on both sides, you get 99% of the data. So 68, 95 and 99 is what I want you to remember. Let's solve a question together. This is the type of question that usually comes in your exam. The global population average of math scores is charted in the graph below. The data is present in normal distribution. Like we say, it's a bell-shaped curve which is symmetrical on both sides. The global mean of all the math scores of students is around 60. So that's the mean, 60, with a standard deviation of 7. Mercurius got, this is our medical student, Paul Mercurius. So Mercurius got a score of 67. He wants to know how many students have the score between 53 and 67. So let us look at the mean. The mean for this example is 60. Okay, you add one standard deviation up, that would make 67. So that has 34% of the data. So 34% of medical students lie from 60 to 67. If you minus 7 from 60, which you go somewhere around here, that's 53, right? You minus one standard deviation from 60, which is here, and you get another 34% of the data. So how many students have score between 53 and 67? Exactly, 68%, because that's exactly one standard deviation in the forward direction and one standard deviation in the backward direction. So therefore you have 68% of medical students from 53 to 67. Let's talk the takeaway from this lecture. The takeaway from this brief lecture is positive skew is written like a P and positive way is the right way. Mean and then negative skew is of course the opposite of it, and then you remember it from the positive skew, which is written like a P. So mean is basically the class average. You take the sum of all the values and you divide it by the number of values. What is the median? Median is the middlemost value. Mode is the most repeated value. In a positive skew, remember the readings are skewed towards the smaller side and they form the P. Therefore, the mode, which is the most common, if the peak occurs earlier, so they're skewed toward normal, toward the lower side. Therefore, mode is the smallest thing. Median is slightly bigger and mean is the biggest value in a positive skew. In the negative skew, you have the absolute opposite of it. The mean is the smallest value because most of the readings are skewed towards larger value. Let me draw a graph here again so that you remember and I don't confuse you here. So this would be a positive or right-sided skew. And if we just invert this whole thing, this would be a left-sided skew. So now you understand that this would be mode, median, and mean. Again, mean, median, and mode. So that's how negative and positive skew work with and their location of mean, median, and mode. Lastly, mean plus minus one standard deviation on both sides contains 68% of the data. 2 standard deviation contain 95% of the data, and 3 contain 99% of the data. Lastly, thank you so much for watching this video. If you like my video, please make sure to watch the rest of the series and subscribe to my channel. Future belongs to those who believe in the beauty of their dreams.